So for this example, we read it. A large box contains many plastic syringes, but previously experience indicate that 10% of the syringes are defective. So 5 are taken from the box. When you're talking about syringe, discrete or continuous? Discrete. So X is number of syringe. So discrete, you have two ways to think about it, binomial or Poisson. When you read this question, it's talking about binomial or Poisson. Obviously binomial lah, because binomial they will give you how many sample that you have, and then what is the situation of your string. So your sample here is binomial. You have 5 string, which is 10% are defective, so 0.1. So number of string that are defective. So binomial kena bina ayat dia, berapa sampel, apa keadaan dia. What's your N? What's the situation P? So you can notice that our question, among these 5 strings, they are talking about defective. Defective, how many? None of them defective, at least 2 defective. So dia akan analyze on daripada 5 string itu, bilangan string itu. So for question A, it was still binomial because your sample just 5. Okay, so just binomial. So how many string here? A, none of these 5. So X will be equals to 0. So we use formula, can 5Z 0, P 0.1, power of 0, then Q 0.9, power of 5. So question number 1. Okay, question number 2. How many strings? At least. How we write symbol at least? More than, equal to. So for this situation, we read table. Faster. We can read it straight away. So where's your N5? P 0.5. P 0.1. So find out page. Yeah, page 5. N5, 0.1 here. How much that you want to read? Read for 2. Read for 2, which is 0.815. Okay, so look at question B. Instead of 5 string, so you can see originally our sample is 5 string. Now they replace at 100 string that are picked randomly and removed. So sample kita dah bertukar betul. Tapi we still talking about the string. So number of X distributed binomial, the number of sample is 100. So among this 100, find out the probability at least 15 out of this 100 are defective. Masih lagi keadaan defective, maksudnya masih lagi keadaan 0.1. Dan soalan ni agak baik hati lah. Kenapa kita kata dia baik hati? Sebab dia sebut siap-siap. Dia minta use a normal distribution to estimate these questions. Dia dah bagi hints dah. Faham dah? Dia dah tunjuk dalam kerja. Kamu perlu menjawab soalan binomial ini dengan menggunakan pembenaran kepada binomial. Pertukarannya kepada normal. Boleh. So distribution kita tulis dulu. Okay, sample 100. Situation still same, which is defective 0.1. Okay, so we change to normal. Why we change to normal? Why we change to normal? The first situation, the first condition, N is 100, which is already more than 50. Syarat ni sudah penuh. This condition is fulfilled. Secondly, what's the condition? let us calculate NP 100 times 0.1, which is 10, already more than 5. Third condition, probability dia okay tak? Fall in between 0.1 and 0.9. Normally third condition tu tak effect banyak sangat lah. Very obvious will be condition number 1 and number 2. So this one, definitely you need to change to normal distribution. When we change to normal distribution, what's the parameter that we need? What's the parameter here? We need to find out what is our mean and variance. Okay. So to find out mean, from binomial mean, it will equal to NP, which is 100 times 0.1, which is 10. How about its variance? NPQ, 10 times Q, 0.9. So you get 9. So now our distribution of normal will be having the parameter 10 and 9. Done. Okay, so back to the questions. What's the probability they ask us to find? How many strings here? At least 15. So at least 15, px more than 15. So are we going to use binomial to calculate this? No, we are going to change to normal. Okay, so what is the status for this x? X ni original is binomial. Now we need to change to normal. So I just go give you a flow here. Now your status is come from binomial. You need to change to normal. After you change to normal, yes, we will change it to standard normal in order to draw the graph and can find it from table to get answer. Okay, so what will happen when we from binomial that we change to normal? Continuity correction. So what happened to normal to standard deviation? Z-score, x minus mean minus x minus mu over standard deviation. Betul? So semua konsep berada di sini lah. Balik kepada soalan kita. So tengok x. X adalah distribution binomial. So sekarang, the next step adalah saya kena sisihkan dia jadi continuous random variable dulu. So more than equal 15. Bila continuous kan dia? More than equal. 15 ada kan? More than equal. So dia punya boundary can be start from before 15, which is 14.5. Okay, so simbol just ikut. Cuma yang equal tu tak perlulah equal sebab saya dah jadi continuous. Equal tak apa, tak equal pun kita biasanya. Okay. So now the x here is normal. Status normal distribution, boleh. Sini status dia binomial. Sekarang sudah sisi, maksudnya dia sudah jadi normal lah. So bila dia sudah jadi normal, the next procedure, kita akan tukar dia jadi standard. So 14.5 minus mean. Di manakah mean ini? Mean kita 10. Standard deviation dia 9. Variance dia 9. So standard deviation dia 3. So what is your z-score now? 1.5. Then we can draw the table. To draw the normal graph, standard normal graph ini 1.5. Sangat obviously kita baca terus saja. Obviously kita baca echo 1.5 saja. So kita pergi balik mana table untuk normal, baca 1.5 z-score. Okay, normal. Okay, z-score 1.5. 066 8. So siap dapat jawapan. So what have you need to alert is you have to clear. For every question you have to clear. What is this distribution? Kita bukan hanya jawab macam tu je, bukan jawab buta-buta saja ya. So you kena tahu ini status apa binomial. So daripada tadi soalan kita ada 9 zebra di tempat awam kan. So kalau kamu dah ada binomial, so akan jadi baru ada 9 zebra di tempat awam. So dia punya prosedur akan jadi lain. If you have a wrong concept daripada sini salah, semua salah. Because you can see this flow is linked one by one, step by step. So atas sudah salah, kosong akal.